Okay, so now we're going to evaluate the limit using the graph. And what we need to do here is actually take a look at the graph and evaluate the limit that we're given of the specific function. We don't have the function, we have to use the graph. So in this case, what this is saying is this is our function graphically. We want to evaluate the limit as x approaches -1 from the right. So here's -1. We're going to approach -1 from the right-hand side. Okay, as we approach -1 from the right-hand side, my y value is approaching +2. This is +2 for y. The second part is we want to evaluate the limit as x is approaching -1 from the left. That means we need to come from this side. So here we are where x is -1. We're approaching from the left-hand side. You notice that this circle is open. That is totally fine. We're not evaluating the limit at -1. We're not evaluating the function at -1. We're evaluating the limit, and the limit is the value near as we approach. So as we're getting closer and closer to -1 from the left, my y value in this case is -2. Okay. In the previous portion of this lesson, we also talked about what is happening as we are approaching from both sides. That is what this notation means, the limit of the function as x approaches -1. There is no superscript, meaning not from the left and not from the right. We want to know what's happening at the same time from both sides. So we can see it algebraically, and we can also see it graphically. Algebraically, we're taking a look to see, are these two values from as we approach from both sides the same? In this case, when I'm approaching from the right, my y value is +2. When I'm approaching from the left, my y value is -2, which means they're not the same. Graphically, when I look, what I ultimately want to see is where the two graphs meet up. In this case, they do not meet up. I'm approaching from the right, I'm up here. I'm approaching from the left, I'm down here. So if I were to continue in either direction, my graph would never meet. So in this case, we would say that the limit does not exist. In the case of D, we want to evaluate the limit of the function as x approaches 3. Since there's no superscript, we have to go up to the graph, identify where x is 3, and take a look at what's happening from both sides. Now you notice in this case, as I approach, meaning the graphic portion, the line that connects the graph, I am approaching a y value of 3. But I also have this random point right here. This is an open circle. Based on the definition of a limit, we want to know what is happening to that graph as we approach x being equal to +3. In this case, my y value is also +3. This would be if I were evaluating the function at 3, which if you look down at G, this says evaluate the function at 3. When x is 3, I essentially have 2 points. One is an open circle, one is a closed circle. In this case, I want the value of the closed circle, which is where y is 5. So the answer to G is 5. So here, when I take a look, what is the limit as x approaches -4? Remember, you have to identify where x is -4 and then approach from both sides. So in this case, I need to go to where x is -4. 1, 2, 3, 4. I'm approaching from both sides. So here's my graph. I'm approaching from the right and from the left. My y value is -5 as I come from both sides. So that means the answer to E is -5. In the case of F, G, and H, G, I already showed you the example, but the notation is different. F of -1 means evaluate the function at -1. It is not the limit. The limit is approaching that value. The function evaluated at that value means I've got to look to see what is y when x is -1. When x is -1, I have 2 different points here. In the case of this problem, I am looking for the solid point, which means if I knew what this equation was, I would plug in -1 and I should get +2. This is known as a piecewise function because there's different pieces to it and there's a huge gap right here between the values. Evaluate the function at -4. When you evaluate the function at -4, you should see that your y value is at -5, which was the same value of the limit, which sometimes does occur. You are to complete B on your own and check your answers on Blackboard. We will now proceed to the next page, and I will go through example D. You are to complete example C on your own. When these notes are checked, I will be looking for both of those. Please remember, the answers are posted on Blackboard, but you need to make sure you understand how to evaluate limits on your own. Looking at the graph in example D, we want to evaluate the limit as x approaches -6. Now here, there is no superscript, so we're not looking to see what happens from the left or the right. We're looking at both. So when I go to where x is -6, which is right here, when I'm approaching from the right, I get an open value. It doesn't matter. I'm still approaching of -2. The problem here is I cannot approach from the left-hand side. I do not have enough information. Therefore, I cannot give an exact value for the limit as x approaches -6. Therefore, the limit does not exist. When I'm evaluating the limit as x approaches -5, here I'm going to go to where x is -5. I need to approach this value from x from both sides. When I approach from the right and I approach from the left, I'm taking a look to see what y value I'm sitting at. In this case, I'm sitting where y is -2, so that means the limit is equal to -2. If you take a look at example C for this graph, we are asked to evaluate the limit as x approaches -2 from the left. We have a superscript. That means I am only coming from this side. So I'm going to go to where x is -2, and I will only approach from the left. That means I'm going in this direction. My y value, where am I sitting right now? I'm sitting where y is equal to 0. Therefore, that limit, which is a one-sided limit, is 0. This is one-sided because we only have to approach from one side. Here, I want to evaluate the limit as x approaches 0. Okay, it's not from the left or the right, it's from both. So the y-axis is where x is 0. When I approach from the left, I'm up here at 2. When I approach from the right, I'm up here at 4. The problem here is I'm approaching two different values from the left and from the right. So we addressed this on the previous page. The limit does not exist because the left and right hand limits are not the same. Evaluating the limit as x approaches +4 from the left. We're going to go up here, find 4, 1, 2, 3, 4. We will approach only from the left hand side, so we're up here. I'm approaching from the left. This value is +6 for y. In the case of the last three, I want to evaluate the function at 1. So here is where x is 1, the y value is 4. Let's evaluate the function at 2. Here's where x is 2. What is the y value? You notice here you have 2 points. One is open, one is closed. Remember what I said in the previous problem. We take the closed value when you're evaluating the function. So in this case, the answer is also 4. Now, evaluate the function at -3. Tell me what that y value is. If you put 0, the answer is correct. What you will now do is proceed and solve examples B and C and check your answers on Blackboard.